fascinating world of our minds, specifically how tiny chemicals and brain regions work together, keep our thoughts sharp, our memories intact, and our mental gears turning smoothly. Let's start with dopamine, the brain's very own feel-good messenger. And think of dopamine as your brain's VIP courier, delivering signals that help us feel motivated, rewarded, and focused. It's especially important in areas like the prefrontal cortex, the CEO of your brain that manages working memory, the mental scratch pad where you juggle numbers, words, or visual images. Within this prefrontal region, dopamine binds to special receptors. Think of these as tiny lock and key mechanisms that regulate neural activity. The way dopamine interacts with these receptors, known as dopaminergic signaling, is crucial for maintaining sharp working memory. If dopamine signaling gets disrupted due to dysfunction in the dopamine system, or working memory can stumble, leading to decreased cognitive and language capacity, or even troubles with visual memory and reading. What causes these disruptions? Well, a key player is the enzyme catechol O-methyltransferase, or COMT for short. COMT acts like a cleanup crew, degrading catecholamines, dopamine, epinephrine, and norepinephrine that flood our synapses, the tiny gaps between neurons. By methylating these chemicals, COMT influences how much dopamine is available to bind to those receptors, especially in the dorsolateral prefrontal cortex, the brain's command center for working memory. Interestingly, COMT isn't a one-size-fits-all. It has different isoforms or versions that can be membrane-bound or soluble. These isoforms can affect how efficiently dopamine is broken down. Certain polymorphisms, genetic variations, can lead to decreased enzyme activity, resulting in higher dopamine levels or vice versa. Sometimes things go awry due to external factors, exposure to compounds like chlorpyrifos, polycyclic aromatic hydrocarbons, or even certain flame retardants like polybrominated diphenyl ethers can interfere with neural activity. These substances may cause neural abnormality, especially in the prefrontal cortex, leading to a state called hypofrontality, basically a less active front part of your brain. Meanwhile, these external injuries can affect gene expression by altering methylation patterns, the addition of methyl groups to DNA, which can turn genes on or off. For instance, methylation of genes involved in dopamine synthesis or receptor function can lead to decreased dopaminergic activity. Understanding these mechanisms help researchers develop strategies to protect our brains, whether through lifestyle choices, medications targeting dopamine receptors, or reducing exposure to harmful substances. After all, keeping our brain chemistry in check is key to staying sharp, focused, and mentally agile. Thanks for joining on the minute adventure through our marvelous machinery of the mind. Keep those neurons firing.